Welcome to a lesson with Dr. Powell. Let's take a look at the idea of a Taylor series expansion set it at a point, or just the idea of how to rewrite a polynomial that's in powers of x as a polynomial that's in powers of x minus 1. So these coefficients, what are they, and how can we obtain them? Well, let's just think about this for a minute. If we were to plug in x equals 1 to both sides right now, what would happen? Well, all these guys would be 0. And then over here, we would have 5 times 1 minus 3 times 1. So that's 2 plus 1. We would get 3. In other words, if you want to figure out what a naught is, or a sub 0, all you do is you just plug 1 into this equation. All these go away, and then you just plug in here. And so basically, it's the same thing as just thinking of this polynomial as a function f of x and simply plugging in f of 1, where we're looking at powers of x minus 1. So a sub 0 is nothing but f of 1. So far, we know that a sub 0 is just simply 3, because we plug in a 1 here, and we get 5 minus 3, which is 2 plus 1. All right, so now, how do we figure out a1? Well, if we could get rid of a sub 0, which we can if we just take a derivative of both sides. Just take a derivative of both sides, the constant will go away. So if you take a first derivative, this is nice, we just get, that goes away, so we're left with just a1. And that's kind of nice because it's a1 times x minus a1. If you distribute, a1 will go away. It's just a1 times x, just a1. That's great. Then over here, use power rule, right? And chain rule. The derivative of x minus 1 is just 1. So you get 2 times a2, the constant a2 times x minus 1, plus other things have powers of x minus 1 in it. Now when you plug in 1, guess what happens? All this goes away. You can ignore it. So we just need to take a derivative of this, which we would get 20x cubed minus 6x. And then we just stick in 1. And we stick in 1 here, we get 20 minus 6, which would be 14. So we know a1 for sure is 14. So far we have a0 is 3, a1 is 14. It's kind of nice. Now, let's think about how in the world we can get a sub 2. Maybe we should write out everything we have in this first derivative. All right. So we end up getting plus 2a2 x minus 1 plus 3a3 x minus 1 squared plus, now keep it, okay, so we could be, okay, yes, we could be writing it like this. Okay, so plus, and this is 4a4 x minus 1 cubed. Okay, now how do we figure out a2? So we need to take a derivative of both sides. Take the derivative of this side, we're going to get 60x squared minus 6. And over here, the a1 goes away, and we're left with 2a2. And here we'll have powers of x minus 1. So when we plug in 1, it'll all go away. So we're going to get 2a2 is equal to this. So if we plug in if we plugged in 1, right? If we plug in 1, it'll go away. It only goes away when we plug in 1, because, I mean, if you work this out, this is, in fact, it'll be good to work it out. Plus 6a3 x minus 1, and this is 4 times 3, right, which is 12. 12a4 x minus 1 squared. So you plug in a 1, this will go away. Over here, you plug in 1, you get 60 minus 6, which is 54. So we know, so 54 is equal to 2a2. So to find a2, you have to divide it by 2, which would be 27. So we know that a2 would be 27. Okay, so we're successful at finding a2. How do you find a3? We'll take a derivative of this side. this part would be 0. Over here, you would have 120x. So you'd have 120x, and that's going to be equal to, that goes away. So then you just have 6a3. And now you have plus 24 a4x minus 1. Plug in a 1, that part goes away. So 6a3 is equal to that. So you divide 120 by 6, and you get 20. So that you know a3 is equal to 20. Now, how do you figure a4 out? You take a derivative on both sides. 120 is equal to, then we have 24 a4. That's it, right? And you divide 120 by 24, and we would end up getting a 4. So let's see about that. So if we did 5, right? So yeah, 5 times that is that. So yeah, so we get 5. So we get a4 is equal to 5. So we've just obtained what these coefficients are. If we want to rewrite this polynomial that's in powers of x in terms of x minus powers of x minus 1. And we did it via a derivative technique. Now, one way of thinking about what's happening is, how did we get a sub 0? A sub 0 was really just plugging in 1 into the function itself. How did we get a sub 1? Well, we plugged 1 into the derivative. Okay. How did we get a sub 2? Well, we plugged 1 into the second derivative, but then we divided by this 2. Divided by 2. Over here, we plugged in 1 into the third derivative, then we divided by 6. Here we plugged 1 into the fourth derivative, and then we divided by 24. Now think about what's happening. Divide by, we're here, this power of 2 was like the power of 2 here, and then we had then over here, we had a 3 come down, then a 2 come down, so 3 times 2. And over here, we had a 4 come down, then a 3 come down, then a 2 come down. So essentially what we're having, notice that this is really 2 factorial. This right here could be replaced with 3 factorial. And this right here could be replaced with 4 factorial. And so we end up getting right here 4 factorial. Okay. So, and this is a way that we can describe just a general rule of how to get the coefficient a sub n. So how do you get the coefficient a sub n? It's going to be the nth derivative. Use this notation for nth derivative here with the parentheses. So nth derivative of f, and you plug in your center. So in particular, if we're looking at powers of x minus a, so here we did 1, but if we did powers of x minus a, we plug in a, and then we divide by n factorial. So this is, and you can kind of see why this is true via this example where we're taking derivatives to pick things out. Then the coefficients here happen because we've repeated derivatives here of this power using the repeated power rule. So that's why we had to divide it over to actually get the coefficient. Thanks for watching.